integer n is selected at random in the range n from 1 to 2020 inclusive. And we want to find the probability that the remainder when n to the 16th is divided by 5 is 1. Well, let's figure out what are the numbers so that this number raised to power 16, when it is divided by 5, the remainder is 1. Let's figure that out. When it is divided by 5, that means mod 5, right? Mod 5. Okay, we want to figure out like what number of n so that the remainder is 1. Please note that we actually only need to consider the unit digits because any other digits that's not unit digits, when it is mod 5, it will be 0. So here's a little reason. For instance, just think about 3 digits number ABC, which is the same as A times 100 plus B times 10 plus C, right? If you mod 5, think about mod 5. These are multiple of 5. They will be congruent to 0. So eventually, you just need to look at the C when it is mod 5. So here, just want to make sure that you know that we only consider the unit digit. Now let's take a look at the unit digits. So when the unit digit is 1 to the 16 certainly is going to be 1 mod, is just 1 mod 5. 2 raised to power 16 is going to be, let's do that, say 2 square raised to power 8, right? Which is congruent to 4 raised to power 8. And 4 is congruent to negative 1 mod 5. So therefore, this is going to be congruent to negative 1 raised to power 8, which is 1 when it is mod 5. Again, I'm using 4 is congruent to 1 mod 5. Mod 5. 3 raised to power 16 is the same as, again, 3 is congruent to negative 2, right? So negative 2 raised to power 16. And we already know 2 to the power 16 is congruent to 1, so therefore negative 2 raised to power 16, the negative sign will be gone. So it's going to be negative, it's going to be 1 again. And 4 raised to power 16, 4 is congruent to negative 1, so therefore this is congruent to negative 1 raised to power 16. This is again 1. And 5 raised to power 16, obviously 5 is congruent to 0 mod 5. So therefore this is going to be 0 mod 5. So you do know that this is not 1, right? This is not 1. Now let's take a look at 6 raised to power 16. Isn't it 6 is congruent to 1? So this is the same as 1 raised to power 16 mod 5. So 6 is congruent to 1 mod 5. Therefore, which is the same as this result. If you look at 7 raised to power 16, because 7 is congruent to 2 mod 5. So therefore, this is going to be the same as this result. Similarly, the 8 raised to power 16 will be congruent to, will be this result. 9 raised to power 16 will be this result. So that's how you do this arithmetic here. And then we forgot to mention that when the last digit is 0, 0 raised to power 16 is certainly 0, which is the same as this result, mod 5. So we have gone through all the possibilities. We already know that as long as the last digit is not 0 or 5, then this n to the 16 should have remainder 1 when it is divided by 5, which is, isn't that 4 out of 5 chance that's happening? 4 out of 5 chances. Is that right? Basically 8 out of 10, which is 4 over 5. So this is one way to do that. Another way that I would like to mention is, because Fermat's little theorem certainly can come in this particular case. What is Fermat's little theorem? It says a raised to power prime minus 1 should be congruent to 1 mod prime. This has to be prime, where p does not divide a, which means a is not multiple of p, or a is relatively prime to p. So therefore we do know n raised to power, n raised to power of 5 minus 1 should be congruent to 1 mod 5, as long as this n is not multiple of, 5 does not divide n. Okay, so 5 does not divide n, which means as long as the number n does not end with 0 and 5, then 0 or 5, right? Then this n raised to power 4 should be congruent to 1 mod 5. Now the question is mod raised to power 16, which is power n to the 4th raised to power 4. This is n to the 16. When this is 1, certainly this is 1, right? Should be congruent to 1. So, the digits end with 0 and 5. It's 2 out of 10 possibility. So not end with 0 and 5, that would be 4 out of 5. So this is another way to look at it.